Welcome to Symposium 4 on Antimicrobial Resistance. I'm Ellen Kirsch from the STD Laboratory Branch at CDC, and my co-moderator is Dr. Sancta Sansur, also from CDC. We will have 4 speakers today, each with a 15-minute presentation. Sancta and I would like to warmly thank them for accepting this challenge, for working diligently on their talks, and having them ready for this recording, which happened on July 30th. Thank you for getting ready so early before the conference. We appreciate it. Because this is a recording, we cannot take questions during the session. However, we encourage you to write them down and ask them during our live Q&A session, which will happen during the conference. It will be on Friday, the 18th from 2:30 to 2:50 p.m. You can email your questions to the speakers ahead of time or to us moderators or ask them live. With that, I would like to now introduce our first speaker, Dr. Laura Bachmann. She is currently the Chief Medical Officer in the Division of STD Prevention and the Clinical Team Lead in the Program Development and Quality Improvement Branch at CDC. Laura has an MD from University of Chapel Hill School of Medicine and an MPH from University of Alabama School of Public Health. Laura, welcome.
Thank you. I would like to thank the organizers for inviting me to speak with you today. As many of you are aware, the 2020 STI Treatment Guidelines have not been released, so I cannot make specific comments about recommendations, but we will talk about emerging themes today. Well, I can't. There we go. Sorry, I have no disclosures. And the outline today, we're going to review the treatment guidelines meeting themes. We're going to focus on some select topics and then some conclusions. So meeting themes. Some of the primary issues that were covered during the meeting, the guidelines meeting, included emerging drug resistance, which is not surprising, especially with gonorrhea and Mycoplasma genitalium, but also enteric pathogens. Resistance-guided therapy for gonorrhea and MGent. And then an emphasis on pharmacokinetic and pharmacodynamic drug properties and by therapeutic agent, anatomic site of infection, and weight. The overarching theme of the meeting related to antimicrobial stewardship and the need to minimize antibiotic exposure unless risk clearly outweighs the benefit. So for gonorrhea, as many of you are aware, for 2015, the only recommended treatment therapy for gonorrhea was Ceftriaxone, 250 milligrams IM, plus a gram of Azithromycin, even if chlamydia is ruled out. And as you'll recall, the rationale for this was really to treat gonorrhea with 2 different antimicrobials that had 2 different mechanisms of action in order to hopefully prevent the development of resistance. Some of the issues we considered when we spoke of gonorrhea treatment related, of course, to the surveillance data, which has historically directed treatment changes in the past and remains very important. Dr. Sancta Sansur will talk about this more today, but also pharmacokinetic and pharmacodynamic properties of drugs specifically for gonorrhea. And the antimicrobial stewardship question, of course, is dual therapy, the risk-benefit of dual versus monotherapy for gonococcal infection. Just to give you an idea of some of the things we discussed, this is a beautiful table that was put together by Dr. Lindley Barbie and Dr. Sancta Sansur related to calculated ceftriaxone doses for various human weights extrapolated from the Murine Model. A Murine Model was used to estimate the PK/PD parameters for gonococcal cure at the genital tract for susceptible and resistant strains. And so we're going to focus on the susceptible strains. Using a range of ceftriaxone, the investigators actually collected serial quantitative cultures to evaluate efficacy. And the lowest ceftriaxone dose that was 100% effective at eradicating the susceptible organism 48 hours after treatment was 5 milligrams per kilogram. This translates into a 5 milligram per kilogram dose, or our current therapy of 250 milligrams translates into 5 milligram per kilogram dose for a 50 kilogram individual. However, the average American is around 80 kilograms, and therefore it translates into a 3 milligram per kilogram dose for those individuals of that average US weight. So if we look at what would mean a 5 milligram per kilogram dose, it would be really a 400 milligram or thereabouts dose. So this is one of the things that was discussed. While I can't get into any specifics, and hopefully that's not too frustrating right now, this is an area to pay attention to when the guidelines come out. Mycoplasma genitalium is an emerging or has emerged pathogen. It was included in the 2015 guidelines in the emerging pathogen section, and for 2019, it actually made a watch list for resistant M-gent infection. So this is the first time it will have done that. We know that M-gent has been associated with a variety of STI syndromes, adverse reproductive health outcomes, and HIV, though the data is strongest for NGU. We know that Mycoplasma genitalium prevalence is pretty high, actually, in at-risk groups, ranging, there's a broad range from 3 to 42%, but it's consistent with what we would see for an STI. But these are data from a recently published study that was conducted among 6 US STD clinics, and this is specifically a study of men presenting with urethritis that was confirmed microscopically. As you can see, the prevalence of M-gent is high. Almost a third of the men had M-gent present, and it ranged by geographic location, peaking at around close to 40% in Greensboro, North Carolina. Of the men with M-gent, a high prevalence had resistance. So the 23SR RNA macrolide resistance mutation confers resistance to azithromycin, or is highly associated with clinical failure. The PAR-C fluoroquinolone resistance mutation is not as consistently associated with clinical failure, but as you can see, the rates of resistance are substantial and up to 80% in one location. So I don't have time to go through the declining efficacy of azithromycin for M-gent and those data, but suffice it to say we have few antimicrobials for M-gent, and the ones that we have seem to be declining in efficacy. So what do we do about that? Our colleagues in Australia have been using resistance-guided therapy for M-gent since 2015. They've been testing for M-gent a long time. And they use doxycycline for 7 days as empiric therapy for STI syndromes, as well as for contacts to M-gent. As they test for M-gent, those who have it are also tested for resistance. So if the strain is macrolide sensitive, the person is brought back and given a total of 2.5 grams of azithromycin over 4 days. And for macrolide resistant, so that was macrolide sensitive. If they're macrolide resistant, they're given moxifloxacin for 7 days. And as you can see, when they analyze their data, they have quite high treatment efficacy here, higher than what would be expected for azithromycin against M-gent alone at this point. In addition, when they looked at how many, what proportion had selected for macrolide resistance of those who were exposed to the macrolide, that was azithromycin, it was a little less than 4%. But what if we don't have a resistance test available and M-gent is identified? And that is the situation currently in the United States. We do not have a resistance test. Well, theoretically, if we had doxycycline as the first line therapy for urethritis, for example, and we identified Mycoplasma genitalium in that individual, then they would be called back and given moxifloxacin for 7 days. In areas that have low macrolide resistance, though it's not clear where those areas are at this point in time, you could theoretically follow the doxycycline with a higher dose of azithromycin. Unfortunately, this would lead to quite a bit of moxifloxacin use, and it has attendant side effects as well that we need to consider. So in summary, Emergence is common in men with urethritis. That's well documented. Resistance to macrolides is common, and fluoroquinolones is not uncommon. Therapeutic options are limited, and resistance-guided therapy holds promise, but while we don't have testing in the US, it's not clear the best way to go with this given the quinolone overuse potential. Now for chlamydia, like Emergence and declining efficacy, in this case, the efficacy of our first-line therapy, azithromycin, for urogenital chlamydial infection, we're finding may not be quite as good as we thought initially. Now, this is a group of studies. There are different populations, different ways the studies were conducted, but you can see there's a trend for those blue bars, the azithromycin, to be lower than the green bars, the doxycycline. This finding is even more dramatic for rectal chlamydial infection, where azithromycin efficacy ranged anywhere from 79 up to 92%, and doxycycline significantly higher at 94 to 100%. But also, it's important to understand that these are not data from a randomized controlled treatment trial, which would be the gold standard. So as we talked about chlamydial therapy, one of the things that came up is it time to change the recommended regimen from azithro to doxy? And there are lots of things to consider for that. There were individuals who have concerns, real concerns about adolescence and adherence. Doxy's not been studied for EPT. We know, on the other hand, that women not uncommonly have rectal chlamydial infection. And if there's a big difference in efficacy for azithromycin for rectal infection, we could be undertreating that case. And then there's the collateral damage from azithromycin use that we're starting to accumulate more data about. I would encourage you to tune in to the results from a randomized controlled trial for rectal chlamydial infection that is going to be presented by Dr. Julie Dombrowski in a late breaker during this meeting. So vaginitis. We knew prior to the 2015 guidelines that 7 days of metronidazole was more effective for Trichomonas vaginalis infection in women living with HIV compared to single-dose metronidazole. Since the publication of those guidelines, Dr. Kissinger has published another study which demonstrates the same for women who are not living with HIV. So while trick resistance has not increased significantly, or so it seems, since the last guidelines meeting, we're learning more about the need for multiple dose therapy of metronidazole for trick. Recurrent BV is a bane of existence for providers and patients alike, and is common up to some women up to 50% of the time have recurrence. So reasons are unclear. It's still a lot to work out about that. Is it reinfection with other organisms? Is it inadequate length of therapy, persistence of an unidentified host factor, or some measure of resistance? It's not clear. There is building evidence and several studies now that document that there is a multi-species biofilm present on the vaginal epithelial cells of women who have BV, and that this biofilm becomes metabolically inactive upon treatment, and then that in turn leads to decreased susceptibility to antibiotics. So that concept's behind some of the newer therapeutic agents that are being studied, as well as the use of boric acid that you see for recurrent BV. However, another hypothesis relates to the failure of lactobacilli to recolonize. And along those lines, there was a recent study published in the New England Journal of Medicine by Cohen and colleagues. And what they did was they evaluated Lactin-V, which is a live biotherapeutic product that contains naturally occurring Lactobacillus crispatus, versus placebo. And they studied this regimen following 5 days in both groups of metronidazole topical gel. And as you can see here, the group that received the Lactin-V had significantly less recurrence at week 12 and at week 24 than the placebo group. So this is very promising. We don't have, this is not on the market, but it's very promising for the future. So in conclusion, there were a lot of hot topics and new science discussed at the meeting. And I'm sorry I can't get into more detail today, but please stay tuned for the treatment guidelines and anticipate that there will be several changes based on some of the themes we discussed today. I would like to thank the guideline co-authors, especially Dr. Kim Workowski, who leads this effort, but also there are many, many others who contribute significantly to the STI treatment guidelines process. There were so many names to put on the slide, but it takes a village, and I want to express my appreciation to those individuals as well. Thank you.
Now I'm going to introduce our next speaker. Dr. Lisa Manhart is professor in epidemiology and global health and is associate dean for research at the University of Washington School of Public Health. She received an MPH from Tulane University and PhD from the University of Washington. Today, Dr. Manhart will be presenting U.S. multi-jurisdiction surveillance for Mycoplasma genitalium. Dr. Manhart.
Thank you, Sancta. And I'd like to thank the conference organizers for inviting me to participate in this symposium and to share with you our project to develop a surveillance system for Mycoplasma genitalium. In terms of disclosures, I have received speakers' fees, research support, and donations of research materials from Hologic, as well as honoraria for service on scientific advisory boards for Nebriva and for Hologic. We've named our study the Mycoplasma genitalium in the US, or MyGenius. And although I have the opportunity to share with you some information about our project, this really is the product of the work from a large team. We have a large group of investigators who are our site PIs, as well as both Gina Leipertz and Arlene Senya, who contributed substantially to the initial protocol development. And funding for this project is provided by Hologic. So Mycoplasma genitalium has been on our radar for a little over 30 years. And Laura just gave a really nice overview of some of the challenges. This organism was identified in the early 1980s. Today, it accounts for 20 to 30% of male urethritis cases, so not insubstantial. However, there is still a lack of consensus over the role of M. genitalium in female reproductive tract syndromes. Two separate meta-analyses actually arrived at somewhat different conclusions. Widespread testing has only recently become available as FDA-approved assays have emerged into the market in the United States. So because of that, most of the data that we have and most of what we know about M. genitalium has come from research studies that really address a very specific population, often in a very specific geographic area. The only population level estimates of M. genitalium prevalence are actually quite old. They date from the early 2000s. So despite many, many advancements in the epidemiology of M. genitalium, there still are a number of things that we don't know. Complicating this background, as Laura alluded to, is the ability of M. genitalium both to rapidly develop antimicrobial resistance and for that antimicrobial resistance to rapidly expand. These are data from a recent meta-analysis that was published at the end of July of this year. And that meta-analysis sought to estimate the global prevalence of both resistance to macrolides and quinolones. The range of the prevalence of resistance globally is very broad, from 0 to 100% in some locations. That 100% is from Greenland. And overall, the global summary estimate or global estimated prevalence across time and location is about 36%. And looking at this map, you can clearly see where the highest prevalence of resistance is. Asia Pacific, down in the lower right-hand corner of the slide, Australia and Japan. A few select spots in Europe and Scandinavia, and then here at home for us in North America. The global prevalence of resistance in the United States is estimated at about 57%. Again, this is across geographic location and time. The picture of quinolone resistance, at least in terms of the distribution of prevalence, looks very similar to what we see for macrolide resistance, not surprisingly, just somewhat lower prevalence overall. But the places with highest prevalence of resistance are the same. So the range is 0 to 29%, and the global estimate is approximately 8%. In the United States, the summary estimate of quinolone resistance is about 11%, so not inconsequential. So against this background, we thought carefully about whether there is a good rationale for establishing a surveillance system. And I think the answer to that question is yes. We really do need systematic surveillance data in order to do a number of things: to guide treatment decisions for STI syndromes, to help us define the public health importance of M. genitalium. There is still debate about this, to understand the distribution of antimicrobial resistance in the United States. There are very likely differences geographically, and it's important for us to know those, particularly given Laura's comment about our current situation where we aren't able to detect macrolide resistance in FDA-approved assays in the United States. And then finally, we really need to be able to monitor changes over time to see if prevalence is increasing or decreasing, and to see if resistance is increasing or decreasing. So we decided, of course, that it was relevant to establish this multi-site surveillance system. And our surveillance project has 3 goals. The first is to monitor the prevalence of M. genitalium infection over time. Second, to monitor the prevalence of antimicrobial resistance to both macrolides and quinolones. And third, to monitor the relative contribution of M. genitalium infection to our reproductive tract disease syndromes, urethritis, cervicitis, pelvic inflammatory disease. We established in the MyGenius project 8 surveillance sites. These are public STD clinics that routinely use the Aptima Combo 2 test to detect gonorrhea and chlamydia. Our goal was to get some type of regional representation. So our sites fall into 4 regions, and we selected 2 sites from each region. So in the Northeast, we have New York City and Baltimore. In the South, we have Birmingham, Alabama, and Winston-Salem, North Carolina. Midwest is St. Louis and Indianapolis. And then in a very broad swath of geography in the West, we have Denver and Seattle. We selected these clinics primarily for the existence or possibility of a strong academic public health partnership in order to facilitate setting up and implementing the entire system. The data collection plan is to have 2 data collection cycles per year, each of them up to 3 months duration, but they can be shorter if specimens are collected sooner. Remnant Aptima Combo 2 specimens will be set aside, and we will select these specimens based on distribution of specimens from symptomatic and asymptomatic men and symptomatic and asymptomatic women. That will result in a total of 400 specimens per site, per cycle, for a total of 3,200 specimens that will be tested in each data collection cycle. We also will abstract surveillance variables from the medical record. These are those characteristics of persons who are tested that we want to explore and be able to stratify analyses and present different estimates of prevalence in each group. That is sex, age, race, symptoms, of course, clinical diagnoses, and sex of sex partners. M. genitalium is detected using the Aptima-MG assay. Macrolide resistance mutations will be detected using analyte-specific reagents on the Panther instrument. And then Quinolone resistance-associated mutations will be detected using a proprietary procedure at Hologics Research Laboratory. Our plan for the initial year of data collection in this project was to finalize our protocol by February of this year and launch our first data collection cycle in March. After 3 months, we anticipated testing complete data analysis, and my goal had originally been to present the results of that first round of data collection here in this symposium. As we all know, the reality is that COVID-19 emerged in January, a little bit earlier in other parts of the world. We managed to get our protocol completely developed, so we do have a protocol ready to go, and most of our approvals are in place. But given the COVID-19 situation, our STD clinics are seeing very few patients right now, and we have not yet been able to start data collection. We did, however, learn, despite the fact that we haven't started data collection, we've learned a couple of important lessons that I wanted to share. One of them is that approvals required to set up a surveillance system really varied substantially across our sites. The surveillance, as many of you know, is classified as a public health activity, which means in the research world, it is not considered a human subjects research activity and therefore generally does not have to undergo official institutional review board review and human subjects approvals. Some sites, this was well accepted and they rapidly received their exempt approvals. In other sites, this was not so well approved or well considered, and several were required to actually submit to the protocol for an IRB approval and actually develop global consent processes in their clinic. I think the second critical lesson that we learned is the importance of strong academic public health partnerships. Approvals proceeded very quickly in sites that had strong partnerships between public health clinics and academic institutions. But there were some challenges in sites where these partnerships were not as strong. In one site, the academic public health partnership actually dissolved while we were setting up the protocol, and we were faced with having to identify an alternative site. And in another site, the partnership was actually brand new and is developing, but because they're in the process of developing this partnership, some of the implementation details still need to be worked out. There are a number of strengths and limitations to this project. I think the clear strength is that this really will be the first systematic surveillance of M. genitalium done in the United States. It will provide, I think, some very important information. We have some geographic heterogeneity to begin to see how prevalence and resistance varies across the United States. Granted, it is somewhat limited, but we'll be able to expand this to other locations in the United States after this initial proof of principle project. We're using very sensitive and specific assays to detect M. genitalium and to detect antimicrobial resistance. There are limitations also, of course. Clearly, STD clinic attendees are different from the general population, and our surveillance really will be primarily of high-risk populations. Given these differences between sites, we did end up with somewhat different procedures across sites, which we'll need to take into account during the analysis of the surveillance data. But I think the most important limitation, of course, for all of us right now is the COVID-19 pandemic and the unpredictable nature of it. And because of that, the start of data collection for this project is still unknown. We are set up and ready to go, and as soon as clinics are able to open more widely, we will start data collection. And the next time I'm up talking about this project, I will have results to share. I wish very much that this symposium could have been done in person. I'm sorry that I'm not able to answer questions immediately. But I look forward to receiving your questions and to seeing you at the live Q&A session. Thank you very much.
Thank you, Lisa. Excellent. I would now like to introduce our next speaker and my co-moderator and colleague, Dr. Sankta Sensur. She is a medical officer and the GIST project officer in the Division of STD Prevention here at CDC. Sankta holds an MD from Louisiana State University Health Sciences Center in New Orleans and an MPH from University of North Carolina at Chapel Hill. Sankta, welcome.
Thank you, Ellen. So thank you for the introduction and thank you for the invitation to speak. So Neisseria gonorrhoeae's ability to develop or acquire resistance and retain these mutations has made it an urgent U.S. and global threat. Today, we will quickly review the history of antimicrobial resistance in gonorrhea. We will then spend some time looking at susceptibility patterns globally and in the U.S. Lastly, we will see how molecular data can aid the monitoring of susceptibility patterns and end with some goals we as a community can work to achieve. So let us begin. Here is a timeline of when different antimicrobials were first used in gonococcal treatment. The orange bars provide the duration of use before the emergence of resistance. Sulfur drugs were first introduced for gonococcal treatment in the 1930s, and resistance quickly developed by the 1940s. Penicillin was able to have a long life due to its safety and tolerability at increasingly higher doses, but the 1970s brought penicillinase-producing Neisseria gonorrhoeae plasmids, which brought the penicillin era to an end. The 1980s introduced cephalosporins and fluoroquinolones, but by the early 2000s, gonorrhea had developed resistance to fluoroquinolones like ciprofloxacin. Now, we are left with cephalosporins, specifically ceftriaxone, as the backbone of empiric gonorrhea treatment. Let us now transition to global susceptibility patterns. The WHO collaborates with multiple laboratories and surveillance systems as part of the Gonococcal Antimicrobial Surveillance Program, or GASP. This program, established in 1990, requests that each participating country collects and submits data for 100 representative gonococcal isolates per year. The data from each country are combined during analyses, but it should be noted that not all aspects of the program are standardized. The minimum inhibitory concentration, or MIC, is the lowest concentration of an antibiotic that inhibits visible growth of bacteria. MICs identified by different quantitative methods can sometimes provide slightly different results. These methods, agar dilution or MIC gradient strips, can be used with different culture media, which can also return slightly dissimilar results. The method of testing and the media used are important because the MIC values are used to determine susceptibility and resistance categories. How each MIC value is classified varies depending on which organization's definitions are used. Despite these limitations, we can still visualize global patterns. In 2019, the 2016 GAS data from 67 participating countries representing each of the 6 regions around the world was published. The WHO historically has used an arbitrary cutoff of 5% decreased susceptibility or resistance to identify when an antimicrobial should be reviewed for discontinuation as an empiric agent. It should be noted that the WHO uses the term decreased susceptibility when a recognized category for resistance has not been defined. Ceftriaxone, our main drug for gonococcal treatment, demonstrated a decreased susceptibility prevalence above this cutoff in over 10% of reporting countries. Azithromycin is often used in combination with ceftriaxone to delay ceftriaxone resistance. Almost half of reporting countries demonstrated decreased susceptibility to azithromycin of at least 5% prevalence. And ciprofloxacin, a once convenient, effective, single-dose oral drug, demonstrated resistance at this level in almost all reporting countries. Some countries that report data to GAS maintain and publish data from their own surveillance systems for gonorrhea. Australia, the UK, the US, and Canada all have surveillance systems. Europe also has one where the UK and 26 other member states contribute data. Just like the WHO's GAS, the 5 national surveillance systems use classifications of resistance or decreased susceptibility that are not always the same. Here you see some of the MIC cutoffs may be the same for some surveillance programs, but different for others. Even with slightly different cutoff values, we can evaluate the prevalence of resistance or decreased susceptibility to each drug over time for the 5 national surveillance systems. For ceftriaxone, we see that as of 2017, all programs had a prevalence of decreased susceptibility below 1%. Canada, the purple line, was the only country above 1% during 2012 to 2016. The decrease to levels similar to other countries featured is likely multifactorial. On this graph, we see that the prevalence of azithromycin decreased susceptibility has gone up since 2012 for all surveillance programs. In 2012, none of the programs had a prevalence above the arbitrary 5% cutoff. Now, Europe is above 13%. Australia and the UK both have their most recent prevalence, and the US is the lowest with a prevalence of about 5%. This trend is responsible for many discussions of removing azithromycin as part of combination treatment with ceftriaxone. Unlike ceftriaxone and azithromycin, the prevalence of ciprofloxacin resistance was already high in 2012 in all surveillance systems. Apart from Australia, ciprofloxacin resistance was higher in all programs in 2018 than it was 6 years prior. I'll now discuss US susceptibility patterns. As noted earlier, GISP is the US Sentinel Surveillance Program for Antimicrobial Resistance in Gonorrhea. It was established in 1986 to perform 2 main purposes. 1, to monitor gonococcal susceptibility trends, and 2, to use that information to inform gonococcal treatment recommendations. In GISP, we monitor antimicrobial trends over 3 decades. Looking at our preliminary 2019 data, we see patterns similar to the 2018 data visualized with the other national surveillance systems. Let us look more closely at ceftriaxone, azithromycin, and ciprofloxacin. Azithromycin, here in the green bars, has demonstrated a steady rise in the percentage of isolates with decreased susceptibility since 2012. For the past 3 years, the rate of that rise appears to have slowed to the preliminary 2019 prevalence of 4.9%. The prevalence of decreased susceptibility to ceftriaxone, represented by the gold bars, has remained low and relatively unchanged. In 2009, it was 0.3%, and preliminary 2019 data show 0.1%. This graph shows the clear increases in ciprofloxacin resistance. Ceftriaxone and azithromycin are left here as relative comparisons. After ciprofloxacin was no longer recommended for treatment in the US in 2007, there was an initial decline in prevalence of resistance to 9.6% in 2009. Since then, resistance has continued to increase, with 2019 demonstrating its highest level to date in the US, 35%. Despite the steady increase, research and new diagnostics identifying the causative mutations are finding ways to offer ciprofloxacin as treatment in specific populations. Overall, if we look back at susceptibility data from a decade ago and compare it to now, two major points can be highlighted. Let us look at the green section of the chart. In 2009, over 3/4 of the isolates collected through the Sentinel surveillance program were considered susceptible. Now, preliminary 2019 data show that the percentage of susceptible isolates has decreased to less than half. If we look at isolates with resistance or decreased susceptibility to 2 or more antimicrobials, the orange section of the charts, this has doubled in 2019 to 20% from 10% in 2009. These 2 points highlight the persistence of resistance among older drugs and the increasingly limited options for current therapies. Now to molecular data. Molecular studies looking at genetic material and resulting proteins can be used to understand antimicrobial resistant gonorrhea. Specifically, molecular data can 1, identify old and novel mutations in gonorrhea that cause resistance, 2, understand patterns of transmission that can be used to respond to outbreaks, and 3, function as surveillance of known and new gonococcal strains in a community over time. Whole genome sequencing, determining the complete DNA of a gonococcal isolate, is one form of molecular evaluation. On this slide, we see that prior to 2017, GISP isolates underwent whole genome sequencing as part of studies or special evaluations. In 2017, regional laboratories began sequencing systematically selected isolates. As a result, the amount of sequencing of GISP isolates increased exponentially. In 2017, about 400 isolates were sequenced. In 2018, about 1,500. In 2019 is above 1,800. When resistance is seen, whole genome sequencing can be used to identify the mutation that is leading to resistance. Once a mutation is identified, it can be followed within and between different populations to monitor susceptibility patterns. On this slide, isolates were stratified by those with and without known mutations of 23S rRNA, which are associated with azithromycin decreased susceptibility. Here, the CDC lab was able to look at the azithromycin MIC distribution and identify at which MIC values known variants were identified. Using GISP data, we see the presence of 2 known mutations increase at azithromycin MIC values of 4 and higher. Data gained from whole genome sequencing can also be used to classify isolates into similar groups. One method, multi-locus sequence typing, or MLST, identifies and groups gonococcal strains by known housekeeping genes. In 2018, the CDC lab identified 144 different MLST types in GISP. The most common MLST types are shown. By being able to group similar gonococcal strains, we can monitor changes in prevalence and certain groupings, which can be a sign of changing susceptibility patterns in a community. On this slide, we have highlighted the MLST types seen in isolates with decreased susceptibility to azithromycin by the purple bars. In the top figure, the largest number of isolates with azithromycin decreased susceptibility are sequence types 9363 and 11422. In the bottom figure, we identify sequence types 1579 and 7371, which only consist of isolates with azithromycin MICs of 4 or higher. Lastly, Molecular data can be used to follow mutations and sequence types over time. By identifying and monitoring sequence types, we can look at relatedness of different circulating gonococcal strains in a community. Here, sequence type 1584 is highlighted. We can visualize the relatedness of all isolates with this sequence type via a phylogenetic tree. We can see the years each isolate was collected, the isolate's MIC to azithromycin, and the presence or absence of known resistant conferring mutations. Over time, we can monitor the increase or decline of different strains in a community. Molecular data are becoming more widely used in surveillance to identify, group, and follow gonococcal infections at both an individual and a community level. Routinely incorporating these data into our surveillance can help us more efficiently respond to susceptibility changes through public health interventions. So our goals. I'd like to close with highlighting the 4 main goals I think we can address as a community to limit the impact of antimicrobial resistant gonorrhea. First is limiting the transmission of resistant gonorrhea. This requires timely testing, identification, and treatment of resistant strains. Second is optimizing treatment to currently available drugs. In the US, discussions have occurred around what is the best empiric regimen for gonorrhea treatment. Drugs, doses, and the need for antibiotic stewardship for gonorrhea and other bacteria are shaping the upcoming updates to the gonococcal treatment recommendations. Next is improving our current surveillance efforts. Globally, there needs to be an expansion in locations conducting surveillance and a standardization of surveillance work. Although not discussed today, treatment failure surveillance, which is currently not widely done, should also be considered. Lastly, investments in new diagnostics, drugs, and therapies, including vaccines, will help us stay ahead of gonorrhea's infamous ability to overcome our treatment efforts, and Dr. Taylor will discuss these further. This is truly a team effort, and I would like to acknowledge my colleagues at CDC, all of the Sentinel sites, prior GIST regional labs, and current ARLN laboratories for their contributions to the success of the project over the years. Thank you, and I look forward to gaining some questions from you all. Our next speaker is Dr. Stephanie Taylor. She is Professor of Medicine in the section of Infectious Diseases at Louisiana State University Health Sciences Center, New Orleans. Dr. Taylor is also the Medical Director of LSU STI Program, LSU Crescent Care Sexual Health Center, the LSU Infectious Diseases STI Research Laboratory, and the Louisiana Office of Public Health STD HIV Program. She received her MD from LSU School of Medicine. Today, Dr. Taylor will be presenting Evolving Approaches and New Antibiotics for Treating Gonococcal Resistance. Dr. Taylor.
Hello, thank you so much for that introduction, Dr. St. Cyr, and I also want to thank the committee for the invitation to present today. So for a number of years, we've been very concerned. But first of all, let me just show you the disclosures. I do have disclosures related to the clinical drug trials that will be presented today by AstraZeneca/Entasis and GlaxoSmithKline. So as I was mentioning, for a number of years, we've been concerned about developing resistance in gonorrhea and the lack of antibiotics in the pipeline. So I'm pleased today to be able to present a couple of new approaches as well as a couple of new antibiotics that are under study to treat resistant gonorrhea right now. So as Dr. Sancta mentioned, Neisseria gonorrhea has developed resistance to every antibiotic that has ever been recommended for treatment. And especially right at the moment, only the cephalosporin class remains, and there is still a real possibility of resistance or no antibiotics being able to treat gonorrhea. We have had treatment failures, even to the cephalosporins that are the last class, and also other oral cephalosporins in the United States and in other countries. And once again, clinical failures have also been noticed with both high and low dose of Ceftriaxone in Japan, Australia, and Europe. And this is another way to present the development of antibiotic resistance over the years. And I like it because we mentioned and we say pipeline all the time, but if you'll look, this graph on the x-axis has the year, and on the y-axis has the genetic mutations responsible for resistance. But you can see how the pipeline was large to begin with years ago, and it has now become a very tiny pipeline, or some would say no pipeline, actually. So the CDC has had to revise the guidelines 3 times over the last decade due to treatment failures and also due to decreased susceptibility of Neisseria gonorrhea that's reported by the GIST program that we just heard about. The first revision was to remove fluoroquinolones. The second recommended the use of dual therapy with cephalosporins and azithromycin, and that was oral at the time, or doxycycline as a substitute for azithro if patients were allergic or intolerant. And also the third set of revisions removed the oral cephalosporins as first-line therapy. So we used all injectable cephalosporins. So as I mentioned, there are a couple of new approaches for treating gonococcal resistance, and these are a couple of evolving processes that I'll share today. So we've already talked about the resistance mechanisms some, but 3 of the main ones are mutations in the target proteins on the organism, also cell wall components that are changed, and then increases in the efflux pumps that organisms have. In addition, we've also seen over time that if you change the antibiotic recommendation or guideline or resist or restrict or remove an antibiotic from the community for a period of time, then susceptibility does improve or return. So these major shifts in antibiotic use can modify the ecology of drug resistance. And so one approach is the return to previously recommended antibiotics. Once they've been out of the community for a while, not recommended, they do the sensitivity or the susceptibility can improve or is seen to improve in several antibiotics. So we can detect the genetic mutation that is responsible for resistance, and I'll present some information on ciprofloxacin. So we do know a lot about ciprofloxacin gyrase A mutation, and it is the target of anti-gonococcal activity. So there is or have been a couple of assays that are validated, which will help determine whether the wild type organism is present, therefore still sensitive to ciprofloxacin, or if the gyrase A mutation has occurred and that is responsible for resistance to ciprofloxacin. And so there was a study, and Jeff Klausner has done a tremendous amount of work with the gyrase A mutation and ciprofloxacin and reintroducing it into a clinic population. And so, as I mentioned, it's been a validated assay. The sensitivity and specificity are 93% and 100% respectively, and that is compared to standard antimicrobial susceptibility, which we know will take days, and so it's a very long process. So using this assay and others that are going to be developed for different antibiotics, we can actually individualize treatment. So we can detect the wild type, and then we can use cephalosporin in that individual. The goal, though, over time is to really develop rapid tests, a point of care test that can be used in the clinic, and that will let you know whether the organism is present that day and what the sensitivity is, or that mutation present or absent, and then that is a person you could use ciprofloxacin in and be able to save ceftriaxone. So that is the overall goal, is to be able to save our final class of antibiotics for treatment of gonorrhea. And you can see some of the publications from Dr. Klausner and his team. And so we would hope in the future that other antibiotics would be able to be converted to rapid test as well. And a person will get their answer before they leave the clinic. So the other new approach is the use of meningococcal vaccine for prevention of Neisseria gonorrhea. So we have had decades of unsuccessful development of Neisseria gonorrhea vaccine that has used outer membrane proteins, et cetera. But the meningococcal B vaccine, the outer membrane vesicle, has been used to control meningococcal epidemics in places like New Zealand. And it was noted that this was linked to a decrease in gonococcal infection in New Zealand as well. So they've evaluated the effectiveness of meningococcal vaccine against laboratory confirmed cases in the clinic setting. And we have noticed that that the effectiveness against gonorrhea or against gonococcal infection was 31%, giving encouragement to the fact or the potential to use meningococcal vaccine for prevention of gonorrhea or gonococcal infections. So this, due to this cross-reactivity of antibodies that are probably responsible for explaining why this vaccine may be useful for gonorrhea prevention. And so there is a protocol that is in development currently to evaluate the potential of one of the meningococcal vaccines. And we will be studying whether they will cross-protect against gonorrhea and decrease the risk of gonococcal infection. So now I would like to talk about two new antibiotics for treating gonococcal resistance. So we first, as I mentioned, a number of years, Dr. Boland actually, she published a paper on the emerging threat of untreatable gonococcal infection. This was followed by a listing of antibiotic-resistant threats in 2013. Resistant gonorrhea was on this list, and this list has been updated, and it is still on the new antibiotic resistance threats list. So in 2013, the CDC actually issued a call for action to develop new antibiotics for the treatment of gonorrhea. And then in 2015, the FDA also presented or issued guidance for industry on the development of new drugs. And then in 2016, the World Health Organization also re-emphasized the need for new drug development to combat resistant gonorrhea. So just to touch on the FDA guidance for industry, the general considerations in this guidance are that early phase development needs to be considered, and that the drug development population and efficacy needs to be included. Also, the design, the populations, et cetera, should be really assessed prior and in a real detailed way before enrollment and actually presented to the FDA to get approval or recommendations for going forward. And then other considerations, of course, the pharmacokinetics and pharmacodynamics of these drugs. There is also a fast track designation at the FDA. And so as defined in its name, it is a process to facilitate the development and then expedite the review of these drugs to get them to patients as soon as possible. And so that is to meet unmet needs, and resistant organisms also fit into that category. There's also a QIDP designation. This is the Qualified Infectious Disease Product designation. So this applies to a specific antimicrobial, a specific sponsor, and then a specific use or indication for the drug being studied. So therefore, we can see that it also has to have antibiotic, bacterial, or antifungal drug for human use only for serious infections. And I mentioned the inclusion of resistant organisms in that designation. So we can see the challenge then for sponsors. And so that is not only is it one general type of infection or one indication, but it also has to be one specific organism. So that really limits the use of all of what goes into developing a new drug. The first of these drugs we were privileged to study and to publish with my colleagues in New England Journal of Medicine. And this paper looked at the use of zoliflodacin in gonorrhea. So zoliflodacin has both the FDA Fast Track designation and also the QIDP designation. This drug is being developed solely for the treatment of gonorrhea, and it is an oral drug, and it is a novel antibiotic, unlike any marketed antibiotics. In addition, it inhibits DNA synthesis by the accumulation of these double-stranded cleavages that then interfere with DNA gyrase. So it's similar to fluoroquinolones, but it is active against both fluoroquinolone-resistant vancomycin-resistant staphylococcus, and in addition to those that are resistant to ceftriaxone and Cipro from the gonorrhea standpoint. So the study design, it was a phase 2 study, multi-center, open-label, non-inferiority, randomized control. Both the sponsor and the laboratories were blinded. Evaluated Xolair, obviously, for treatment of uncomplicated infection in both men and women. There were 5 sites, LSU, University of Alabama, Birmingham, Indiana University, University of Washington, and also University of North Carolina. So the sponsors, AstraZeneca, which then Entasis is the antibiotic development arm that split off. And then also one of our sponsors was DMID, NIAID, NIH. Primary objective was whether or to assess the efficacy of the 2 or 3 gram dose compared to 500 milligrams of intramuscular ceftriaxone. In addition, we want to assess the safety and tolerability of those drugs. Determine the microbiological cure rate of rectal and pharyngeal gonorrhea or secondary objectives, as well as to evaluate or look at the clearance of nucleic acid or how long it took for the NAT test to become negative. Also assess the clinical cure and then determine the susceptibility at baseline, and if someone failed therapy, also at visit 2 or at the test of cure visit. There were 180 people enrolled, 18 to 53 years old, in good health. And you can see the eligibility criteria here, which are basically the same for any gonococcal drug trial. Signs and symptoms, gonorrhea in the past 14 days, sexual contact, or someone whose partner was diagnosed with gonorrhea. And with this study was randomized, or randomized 70, 70, 40 to receive those drugs. And this just demonstrates the demographics. There were 93% men enrolled and 7% women. In addition, 93% were non-Hispanic. We also were able to, and privileged to actually enroll men who have sex with men, 40% versus heterosexuals, 54%. 59% African-American and 32% Caucasian. So here are the baseline culture results by site. There were a total of 179 positive cultures. 141 of those, or 79%, urethral and cervical. 23 of those were pharyngeal, and 15 were rectal. And here, for the 2 gram dose, there was a 96% cure rate, for 57, 55, or 57 cures. For the 3 gram dose, there was a 96% cure rate, and for ceftriaxone, 100%. For rectal, these are the cure rates. They're very small in number, but there was 100% cure amongst all drugs. And for pharyngeals, you'll notice only half of them had cures for the 2 gram dose, 82% for the 3 gram dose, and 100% for ceftriaxone. We have here the development or the most common AEs related, and you can see that gastrointestinal were the most common. That is, the gold bars represent all AEs, and the turquoise or green bars represent those related to both of the doses of zoliflodacin. And you can see that was the most common AE. And this just demonstrates the antimicrobial susceptibility. You can see that all of the isolates were sensitive to zoliflodacin. And in these isolates, they were resistant to, or at least had decreased susceptibility to azithromycin, ciprofloxacin, and penicillin. So in conclusion, related to zoliflodacin, it was well tolerated, has a very favorable side effect profile, the efficacy was lower at the pharyngeal site, and there was no difference in the MIC between the enrollment MIC and the test of cure MIC, which directs us to that the issue is going to be the delivery of the drug to the pharynx, and it's not an issue of the drug becoming resistant over time. And that has been noticed historically in pharyngeal infection. So in conclusion then, the single-dose zoliflodacin was effective in eradicating gonorrhea. This drug does show promise, and it has entered into phase 3 studies. The next drug is gepotidacin, and this was published in Clinical Infectious Diseases along with my colleagues. This also is a novel first-in-class antibiotic. It has activity against drug-resistant gonorrhea, including those that are ciprofloxacin resistant, and it selectively inhibits bacterial DNA by a unique interaction on the gyrase A subunit and on the PAR-C subunit. The study's design is very similar. We tested 2 different doses of gepotidacin. There were 12 sites in the 12 sites overall, 11 in the United States and 1 in the United Kingdom. Both the sponsor and the sponsor and the lab were blinded once again. This study was supported by GlaxoSmithKline and also NIAID for scientific support. It was funded in part with federal funds from the Office of the Assistant Secretary for Preparedness and Response, Biomedical Advanced Research and Development Authority, or BARDA. The objectives were the same. First of all, effectiveness of the drug, secondary safety and tolerability, and also looking at the effectiveness of the doses in pharyngeal and rectal gonorrhea. In this trial, we had 106 individuals enrolled. The eligibility criteria, same as with most gonorrhea drug trials. This time randomized 1-to-1 to receive either the 1,500 milligram or 3,000 milligram dose in a single dose. There were 106 participants enrolled, 101 men and 5 women, 48% African American, 46% white, and 6% other. So here are the results: baseline cultures by site. Urethral and cervical, 69, they were all positive. For pharyngeal isolates, once again, the numbers were small. There was 3% positivity or 2 cultures positive, and for rectal, 4%. Once again, let's look at the cure rates. So for urogenital, the cure rates was set 97% for the 1,500 milligram dose and 95% for the 3,000 milligram dose. So that was 37 of 39 and 29 of 30. The rectals, small numbers, 100% sensitive. Pharyngeal, we can see once again only 2 isolates. One of them was resistant. Now, looking at the non-solicited AEs, once again, across all doses, or both doses of gepotidacin, you can see that it's once again pretty much all GI manifestations or AEs. Susceptibility data for gepotidacin, all isolates were sensitive. Ciprofloxacin, they were resistant ciprofloxacin, penicillin, and tetracycline isolates. In this trial, however, there were 3 urogenital failures that had baseline MICs of 1, which was the highest MIC noted amongst all isolates. In addition, sequencing was done on these isolates. All 3 were quinolone resistant, but they also had a pre-existing D86 substitution of PAR-C that is known to affect gepotidacin binding. So resistance also emerged between baseline and the test of cure in 2 of these failures. The MIC increased from 1 to over 32, and the test of cure isolates were found to have an additional A92T substitution. And that's also a mutation in the gyrase A. Pharyngeal failures happened with no change of MIC, so it is a drug delivery and a drug level challenge in the pharynx. So in conclusion, single-dose gepotidacin was safe and effective in eradicating gonorrhea or Neisseria gonorrhoeae from urogenital and rectal sites. There were pharyngeal failures. That's historic, as I mentioned before. And so gepotidacin does show promise for the treatment of uncomplicated gonorrhea, and it has also entered into phase 3 trial. So our next steps then, I've mentioned the start of the phase 3 trials. They both started and are currently enrolling. Gepotidacin has added a second dose for participants that they will take when they leave the clinic, 6 to 12 hours after the first dose, which is a new concept in treatment trials for an STI clinic. We are single-dosed experts, and this is a good chance or a good opportunity to test this second dose in patients after they leave the clinic. There are no other antimicrobials currently in the pipeline, at least for sure in the United States. And then rapid tests to detect resistance genes that will allow the use of older antibiotics is really exciting and promising, that we would be able to then save ceftriaxone in many cases and other injectable cephalosporins. And then the gonococcal vaccine trials using meningococcal vaccines are almost underway in the United States as well. So as you can imagine, it takes a lot of individuals and also organizations to complete these drug trials. So we first of all need to thank our clinical drug trial participants. Without them, this would not be possible at all. And then the site PIs, site coordinators, the research teams and local lab staffs, of course, NIH, DMID, and NIAID, and specifically Carolyn Deal, Soju Chang and Peter Wolf. We have industry partners, the Central Labs in BARDA, the ID Microbiology Laboratory at UAB that performed all of the antibiotic susceptibility testing. We have statistical and coordinating centers that participate, and also clinical trial research organizations who support these trials as well. So thank you very much for your attention, and I would be happy to take your questions at the live question and answer session during the conference. Thank you very much.
And with that, we would like to thank all our speakers for this excellent session and their presentations. As a reminder, we will have a live question and answer session during the conference. This will be on Friday, the 18th from 2:30 to 2:50 p.m. In the meantime, you may email your questions or attend the live session and present your questions there. Thank you for listening.